Most people use Databricks as a simple notebook or a SQL editor. But as an architect, you know that what is happening under the hood is a complex orchestration of cloud resources. In 2026, the architecture has split into two very different paths: the classic model we have known for years and the new serverless reality. Today, we are deep diving into the control plane, the compute plane, and the massive shift towards serverless. Welcome to Architect Mindset, your blueprint for modern systems. Let us start with the foundation. Databricks is a hybrid SaaS and operates out of a control plane and the compute plane. Control plane is a central management and orchestration layer that hosts backend services managed by Databricks in its own cloud account. It hosts the user interface where you write code in notebooks and manage resources. All notebook code and configurations are stored and encrypted within this plane. It handles user authentication, including single sign-on, and defines permissions for workspaces and data. The execution and timing of data pipelines and automated tasks are managed within the control plane. More importantly, it handles the Unity catalog, which serves as a centralized governance layer for managing metadata and access across the platform. Control plane is designed for high availability and is resilient to regional zonal failures, typically recovering within 15 minutes. Traditionally, the compute plane where Spark clusters actually live resides in your cloud VPC. This gives you the total network control, but it also means you're responsible for the plumbing, NAT gateways, private links, and cluster start times. The data always stays in your storage. Databricks sees it, but it does not own it. Clusters in the compute plane connect to the control plane via a secure cluster connectivity relay using HTTPS port 443, meaning no public IP addresses are required on your cluster nodes. You can further secure this connection using cloud-native tools like AWS Private Link or Azure Private Link to ensure traffic never traverses the public internet. Now the big shift. In the classic model, you manage clusters. You pick the instance type, the worker count, and the auto-termination policy. With the classic compute plane, you have more control over the network configuration, such as deploying it in your own virtual private cloud or virtual network. The concurrency in classic compute is limited by cluster size and configuration. The scaling is manual, but can be configured to autoscale. The cost model is pay per cluster, cheaper for predictable batch workloads. It's powerful, but it's slow, often taking 5 minutes just to spin up. Enter serverless. In 2026, serverless is not just for SQL anymore. It's for jobs and notebooks too. Here, the compute plane moves into a secure, managed environment hosted by Databricks. You don't pick VMs. No cluster setup required. You just run the code. Startup time drops from minutes to seconds. Queries runs immediately. More importantly, you stop paying for idle time. If a query takes 10 seconds, you pay for 10 seconds. But as serverless works on pay per query or workload, it can be expensive for long-running jobs. Whatever compute path you choose, the muscle behind it is Photon. Photon is Databricks' Vectorized query engine written in C++. Vectorized query execution boosts query performance by processing data in batches rather than one row or element at a time. This design helps to accelerate SQL, ETL, streaming, and data science workloads directly on the Databricks Lakehouse. On serverless, Photon is the default and it is hyper optimized. In the classic world, you have to ensure you are picking Photon ready instance types. As an architect, you also need to think about caching. Classic compute relies on local SSDs for fast data reuse. Serverless uses a more sophisticated elastic caching layer that does not depend on a single virtual machine's disk. 2026 serverless now matches or beats classic performance for almost every SQL and ETL workload. So which one do you deploy? Use classic if you need deep customization, like specific Python libraries that require C compilation. Classic is preferable if you need custom network routing via firewalls, specialized GPU instances for heavy model training. Choose classic if you run predictable, long-running ETL jobs or schedule pipelines. Basically, you want cost efficiency and can tolerate slower startup times. But for 90% of everything else, SQL warehouses, standard ETL jobs, and ad hoc analysis, serverless is the modern architect's choice. Serverless are preferred when you need instant availability without waiting for clusters. Basically, you want zero infrastructure management and are willing to pay a premium for the convenience. Your workloads are spiky, unpredictable, or interactive. It removes the management tax and provides a much faster time to value for your business users. For BI teams and analysts who need quick insights and dashboards, serverless is ideal. For data engineering teams running nightly ETL pipelines, classic is more cost effective. A hybrid approach often works best. Use serverless for ad hoc interactive workloads and classic for scheduled jobs. Understanding the plumbing is what separates a developer from an architect. Whether you stay in your own VPC with classic or embrace the speed of serverless, your goal is the same: performance and cost efficiency. Now that we have covered the brain and the muscle, we need to talk about the data itself. Join me next week as we break down the Medallion architecture, how to structure your bronze, silver, and gold layers to feed the AI engines we have built. Subscribe so you don't miss the blueprint. I'll see you in the next one.